Hello everybody, I'm Xavier Ortiz and I will be presenting the project proposing process and quality improvements on a small-scale brewery. Beer dates back to the Sumerians around 6,000 years ago. In fact, the oldest recipe for anything ever found belonged to a recipe of beer. The Sumerians, along with the Egyptians, left carved stone depicting the performance of social and medicinal rituals around fermented drinks. The main process involved in the production of beer is fermentation. Fermentation is a biochemical reaction in which an organism converts a substance into another. Brewing has evolved over the centuries to become what it is today. It is composed of four basic ingredients. The first ingredient is water, and it comprises about 90 to 95% of the beer, depending on the style. The second ingredient is malt barley, which provides the starch that is transformed into sugars. It gives the beverage its color, sweet flavor, and body. Another ingredient is the yeast. Yeast is an unicellular microorganism that belongs to the fungi kingdom and performs the fermentation. It ingests and metabolizes the sugars released by the barley and converts them into ethanol, which is alcohol, and carbon dioxide. The last ingredient is the hop. Those are corn flowers from a plant that provide a bitter counterbalance to the sweetness of barley, as well as aroma and antiseptic properties. There are two main methods of brewing beer. The first, extract brewing, employs the use of a malt syrup extracted from malt grains. The other, all grain brewing, requires the brewer to perform the sugar extraction in a process called mashing. The proposed project will take place in a Nano Brewery. This company began taking its shape in the beginning of 2011 and started operating late in 2013. It is located in the urban center of the town of Manatee and produces around 21 gallons of beer per week. They produce beer of the ale type that include porters, IPAs, and wheat beers. Their current process for brewing is one that employs malt extract as a raw ingredient. The main problem the brewery is facing right now is that the resulting product presents inconsistencies in many of the final characteristics, resulting in lower quality in their offer to the customer. One of the factors, the color, is directly related to the profile of the grains from which the sugars are extracted. The more specialty roast grains are added, the darker the beer will be, and vice versa. Another aspect is the alcohol content of the beer, or ABV, alcohol by volume. This parameter is related to the amount of sugars extracted and the original gravity, which is a measure of the sugar concentration. The third aspect is the body of the beer. It is related to the density of the beer through its final gravity and derives mostly from the temperature at which sugars are extracted. Higher temperatures will yield more non-fermentable sugars, while lower temperatures will produce the opposite, creating a beer with higher alcohol by volume but with less body. All these characteristics have to be within a certain range in order to comply with the National Beer Style Guideline and to satisfy the palate of the market sector, composed mainly of craft beer knowledgeable customers. Also, the cost of malt extract and extract brewing is proving to be too high for production expansion. These inconsistencies mostly derive from the fact that the supplier has most control over what goes into the grain bill for the sugar extraction process. The first objective of this project is then to reduce the costs associated with raw materials in order to have the economic capability of expanding production volume. Also, the project seeks to provide the brewery with more leverage over the variables involved in the extraction of sugars and the profile of the grains used to do so. Finally, the quality of the product in terms of its final characteristics will be improved to a level of acceptable consistency in its main characteristics. Many possible solutions were analyzed, but the most influential one was the conversion of the brewing process from extract to all grain. This conversion has the advantage of providing lower material costs than extract, as well as full control over the extraction process. On the downside, this new process requires an initial capital investment for all grain equipment, as well as being more labor and time intensive. In order to achieve the stated objectives, rate of return analysis will be performed to determine feasibility of acquiring new equipment, as well as a benefit cost analysis to establish the viability of the new process. The current product will be analyzed and parameter distributions will be produced. The results will be then compared to the data obtained from the new process to determine a relative change in quality. The characteristics of the beer obtained in the new process will also be used to perform a capability analysis in order to determine if the absolute standards are met. The process of all grain brewing will be documented to develop maintenance standards for the new equipment. These standards will be then integrated with other aspects of production to design a maintenance system, including a detailed maintenance schedule. The steps needed to complete the project have been carefully arranged and scheduled on a weekly basis. First, the economical aspects of the investments will be analyzed. Then, the new equipment needs to be installed and tested in order to be able to run the brewing process on the third week, and to collect the data regarding the initial conditions of the unfermented beer, as well as taking operational notes. Fermentation, which takes around 2 weeks, will begin on week 5, giving it enough time in week 4 to design the maintenance schedule following the operational notes taken previously. When the beer is ready in week 7, a sample of the beer will be taken to measure the characteristics to be studied and analyzed, employing the productivity maintenance tools. Finally, in weeks 9 and 10, all the results will be compiled to determine whether or not the objectives are met, and the project will be structured and completed. That concludes this proposal presentation. If you have any questions or doubts, or just want to receive more information about this interesting topic, I invite you to contact me at the email provided or over the platform of the course. Thank you for your time and your attention.